So 1997, Kasparov was defeated by a computer. It was the first time that a computer had beat the best chess player in the world. The approach the engineers at IBM had taken was so-called expert-based systems. You would essentially take the best programmers you had, combine that with the best chess players, encode all of their knowledge, and then use the computation of the computer to effectively act on those rules. And the computer could do faster processing than humans, but it was actually just utilizing the rules that the chess players had encoded. So this was last year. Since we defeated the world's best chess player, Go was the next emerging problem. The challenge with Go was that in difference from chess, you couldn't solve it with pure computing power. If you look at chess, you have 10 to the power of 70 possible board configurations. However, if you look at Go, you have 10 to the power of 170, which is more than the atoms in the observable universe. Meaning that if you ask the world's best Go players why they made a certain move, they said they acted on intuition. It felt right. Whereas if you ask the world's best chess player why they made a move, they would say that they made a certain calculation showing that that move was optimal. So we're moving here from playing these systems where we could essentially thus use the pure compute power to these systems which require fundamental knowledge about the subject and even intuition. The question is, what does this mean for education? Does this mean that we could solve some of the challenges in personalizing education and applying machine learning to human learning that were previously unsolvable? Essentially, what these systems do is that they make use of immense amounts of data. So the AlphaGo system, which defeated the world's best Go player, would play countless games against itself and utilize them to optimize its strategy and win over time. So you feed a neural network with immense amounts of data, and then those networks learn to capture the nuances of the problem you're trying to solve. Another interesting application where they had applied this system was for Atari. So essentially, through trial and error, the system had learned to play Atari. And over time, just through pure data, it figured out an optimal move, digging a tunnel behind the bricks with superhuman accuracy, which would let the ball stick there and eliminate all of the bricks. So pure by itself, it managed to figure out new strategies of playing this game. If we apply this to the problem of education, we have immense data sets from online learning, which we can combine with these new machine learning methods to personalize learning to a whole new extent and at a whole new scale. How we've solved the problem of personalizing learning historically has been, to a large extent, the exact same methods we use to solve chess. We encoded a lot about what we knew about the subject, what we knew about the difficulty of the items, what we knew about how students master languages or math. And then we would utilize those rules and act on them effectively. The question is, could we use these methods to move from those pure rules-based systems or simple heuristics to much more advanced representations of learning? Could we move from this to a more advanced system like this, which would represent the items of content in a richer way? So at the company I founded, this is what we specialize in. Using these immense data sets, combining that with new machine learning methods to personalize learning. We're a team of researchers and engineers who's been working on machine learning and data engineering for companies like Google, Spotify, and Boston Consulting Group. And really what the area we're focusing on is the first two steps of Bloom's taxonomy, where we're working on how we can remember and understand. We're also moving into the field of analyzing. And these are really the bars where I think that AI could have a huge impact on learning. And what this means for teachers is that they, over time, can focus more and more on the top elements of Bloom's taxonomy. So today I wanted to show a few use cases where we've applied machine learning on human learning, specifically on these first two blocks. The first one, which has been sort of the holy grail in education technology for some time, is personalizing educational content. The question is really, how could we generate in real time a personalized path for each student, based on a student's knowledge gaps, their needs for remediation, their needs for assessment, their proficiencies? How could we optimize the next content that they see in real time, be it an explanation, question, or a video? One way we've applied this technology to solve the task of personalizing learning is for math. So this is a Swedish product called NE, where we've explored how could we adapt machine learning to personalize the learning of math. So in real time, as a student is studying math, they would repeat information they might have forgotten. We would ask questions which would address a certain knowledge gap, and then introduce an explanation to address those knowledge gaps over time, essentially functioning as a system for their math learning. Taking one of these aspects of the core understanding and remembering of information and automating it using machine learning. In order to do this, we've had to capture a range of aspects about the student. What is the student's knowledge gaps? What's their needs for remediation? What are their assessment needs? What are their proficiencies? As well as a range of parameters about the content. What's the difficulty of the content? What's the assessment value of the content? What's the instructional value of the content? And a range of other aspects, to provide this real-time content personalization to students. Another task we focused on is the identification of knowledge gaps, and in this case, specifically for language learning. So let's say you have a student that are learning to write sentences, and in this case, they're missing TH sounds. Understanding the root cause of this problem is an immensely difficult task. And essentially how we applied machine learning to this system was to use immense amounts of historical data, which we would then combine with their outcomes, and then learn to predict what mistakes a student would do in the future based on their history of mistakes. So based on this student, which are continuously making mistakes of TH sounds, we could recommend the optimal next material or questions to help them master that particular problem. In this case, it was for a Duolingo competition, where we were against tough competition, some prominent researchers from Cambridge, New York University, and several companies specializing in language modeling. And we ended up winning all categories on all evaluation metrics. And what was interesting and striking was that not a single person in our team has any experience learning about language learning. However, we all had experience in the field of machine learning. And using machine learning, we were able to capture the nuances of how students were learning this subject from immense amounts of historical data and directly utilize that knowledge to figure out what the knowledge gaps might be. So in difference from the other competitors, who to a large extent utilized their domain knowledge, like Deep Blue beating Kasparov, we were able to deduce that directly from data, like AlphaGo beating Lise Doll.
She is my mother, and he is my father.
Try mother one more time.
Mother.
Well done. You're truly progressing with the TH sounds.
Another use case of machine learning on language learning is providing real-time feedback on pronunciation. Really scaling the elements of having a personalized English tutor with you in real time giving your feedback. So this is an immensely complex task where you have to capture intonation, you have to capture intelligibility, and you have to capture fluency in these models to be able to provide feedback on pronunciation in real time. So using machine learning, we've also been able to solve this task, where we essentially in real time, as a student is mastering English or other languages, can give feedback on their pronunciation and give them a score. And this is really important because if you look at the US market, 30% of all teachers report feeling underprepared to teach English. Meaning that most students don't have access to this highly effective real-time feedback on their speech, which is having a heavy impact on their overall academic career. So using machine learning, we've been able to automate that task and scale it to every single student. How we position ourselves as a company is as the engine in every single learning product. So we don't build the user experience, we don't develop the content, we focus only on the machine learning piece. And we allow every single education company to incorporate this technology into their products. So if you want to personalize the learning experience after each student, if you want to be able to give real-time feedback on a student's pronunciation, you can incorporate our technology into your learning product and get it out to students. How you do this is essentially through two simple calls to our REST API. So in the case of personalized learning, you send a request of the optimal next item to present to a user. You post back the outcome after that student has interacted with the item. And then we continuously can serve the optimal next recommendation for each student. So by doing this, we're removing the need for building an in-house team of tens of machine learning engineers, data engineers, and infrastructure engineers, and providing this technology to every single education company that wants to bring AI to their products. The vision of the company, why we truly founded it, was to become a content-agnostic player that scaled personalization to all domains. We partner with companies ranging from medical test prep to language learning to K-12 math that incorporate our technology into their learning products. We work across languages, across subjects, to help every student improve their learning outcomes. And the end game for us is truly ubiquity. We think with the help of machine learning applied to human learning, we could provide personalized education for every single student. We could help them master a new language, help them master the core concept of math, and do that on a global scale. And we're very excited to partner with companies who want to be on board on this mission. Thank you so much.